Hello and welcome to Galbraith and Conversation. My next guests today are Tim Burke and Jennifer Davis from Arch Systems. Nice to see you folks, and thanks for coming in.
Yeah, thanks for having us, Trevor.
Yeah, now you are obviously the guys to beat at the moment. You're leading the field really with the tier one manufacturers and been able to optimize their systems literally across the factory and across the world. Some of the stuff that you're doing is quite amazing, quite frankly. So, you know, the appetite for your systems, which a lot of them are AI driven, has changed quite a bit. So maybe Jennifer, you can start off by telling us, you know, how it compares to say last year, and the way that your customers or potential customers are responding to.
Yeah, absolutely. Yeah, I mean, what you just said nails it. If I think about, you know, just 1 year ago in this room, and, you know, shortly after this, we did one of the largest manufacturing shows in Europe at the same time, Hanover. Yeah. And I think about where everyone was positioning as AI at that point, and AI has dominated the conversational landscape heavily in every industry for the last year. I actually think in a lot of ways that's been a huge benefit to some of our customers. I'm looking now at the conversations I'm having today in this room and with our customers for the last few months. Mm-hmm. I think that the understanding of what AI can do is much clearer to our customers now than it was a year ago. I think that the comfort level, you know, a year ago, there was still a lot of uncertainty as to what it could do because there was less of the agentic proof points in the market. Right. Now as things are becoming much more agentic, things are becoming more role-based, things are actually becoming, Tim can speak more to some of the investigatory work that some of these agents can do now. As people are becoming more comfortable and familiar with AI tools just in their everyday life, I think it's easier for them to understand where it can go inside of the factory, and I think that's been a benefit to people. I think they're less fearful of it, and they're much more excited about, like I said, some of the areas where it can enhance their job, rather than worried about whether or not it's going to take their job. They're more worried about how it's going to enhance their day-to-day.
Absolutely.
And I'm seeing that for sure play out.
Yeah, no, I think you're absolutely right. So Tim, I mean, where is this working out in the product level? I mean, where is Arch today in terms of being able to harness AI as a tool?
Yeah, so this is something that's been really exciting for us because, as Jennifer was mentioning, you know, the familiarity with people seeing some of the commercial tools in their daily life, they sort of see what it can do, but that's very different from can it do it in the factory and how far can it go. And we've seen over the last year an incredible increase in the capability of the models that are available to the point now where when we started this, the first use cases were comparatively simple now. It was, can you summarize a dashboard and tell me guidance from it? Can you translate a spoken word and match it to a label? Very useful, but single step. The latest models and the latest agents we have in our product can actually take a root cause, take a defect found at AOI at the end of a line. We did an example of this with a major manufacturer. Took a defect and then investigated on its own through all of the MES data, all of our linked machine data to identify the root cause of that defect in a high runner product and say it was exactly one feeder that caused all of these defects. That one product on its own had $300,000 a year in repair costs due to just fixing these defects. And AI was able to find the root cause in 10 minutes entirely on its own, being triggered by a drop in yield at the end of the production line. Wow. So that is now possible, and we're increasingly seeing that being used. So on the quality side is a big area. On the optimization side, not just investigate major downtimes, automatically investigate every single deviation in cycle time, however small, because they can buck it up and be very big at the end of the day. Right. And then the area we're seeing a lot of interest in now, which is still emerging for us, is helping planners make better production plans and adapt them to conditions as materials don't arrive, as downtime changes the plan, be able to win your week every week with an adaptive plan that's easier to make and is less reliant on a lot of tribal knowledge in somebody's head about how to make it.
Right. Well, you've unpacked quite a lot there, so let's get into it. It sounds like you're using true agentic AI at this point. So it's making the decision that decision is not referred to a human for confirmation at the end?
So human in the loop is still very important, but the question is, what is the human confirming and what are they validating? So what we're able to do now with the AI is it can make its own investigation plan. Like think of a quality engineer. So what are they going to do? I got a defect. Let me pull the data together. Let me do a bunch of queries, make some spreadsheets, make some ad hoc analyses. Yeah. It's doing all of that on its own without any validation because it can do it. But what is it presenting? It's presenting its conclusion and all of its evidence. It's presenting a report. So the role then of the quality engineer, rather than spending 10 hours putting together the data and analyzing it to get to maybe a root cause, it says, here's everything I found. Based on that, I believe it is this. The human quality engineer still needs to review that and take the action, right. But the AI has taken what was a 10-hour investigation to now reviewing the results and deciding if you agree or what it should do differently.
Oh, that's incredible. I mean, all right, so you're really pushing down the agentic route, but of course the next step in AI is super intelligence. Yeah. Is that ever going to happen? I mean, people say that that's the one thing we should avoid.
Yeah.
So do you honestly think, as a software engineer at that end of the market, do you think we're going to be using that or not?
I don't know how close we are to that, but I also don't know how. Like that would obviously be very disruptive and transformational if it were to occur. But when I think about where AI is used in the factory, I actually use a simpler analogy, which I think about it as a robot arm for decision making. Mm-hmm. So anytime there's a repetitive decision being made on a daily basis, and it's a very similar decision, investigate this defect, root cause this downtime, decide if this process is in control. Those kinds of decisions made every single day, those don't need super intelligence. They need agentic, they need a well-qualified model, they need well-structured data, they need the right expert knowledge and the right structure to trigger it, but those things are adding a ton of value today in the factory, right. And the models we have right now are capable of doing a large number of them. Right. So the impact right now in the factory, we don't need to wait for super intelligence. Like it's available now in the latest models when applied correctly with the right knowledge and expert context.
How much of the data and defect data that you're collecting is getting routed back to the designer?
So that's actually a very emerging area. So this is actually had a conversation with a big OEM right now, and that's what they care about. It was on their design side. Yeah. But great, Art, you're in manufacturing. You now have all this information on how the product is running. Yeah. And there's actually a flow both ways. So flow number one is, can you pull in data from design, those design documents, those CAD drawings, those maybe proactive FMEA analyses of how we think it might fail in production. Use that to inform analyses of the shop floor. Mm-hmm. And AI can do that. It can read those documents when properly linked together. Then there's a flow back the other way. Now let's take all of that collected knowledge, right? We have every single production cycle, every single defect. What is the right summary of that back to the designer? What should you do next time? If you were to make this product again or make your next product, how could you improve the ramp time of NPI using everything we learned about what actually happened? And AI is actually very good at summarizing and analyzing that complex data into a simple recommendation or a series of bullet points. Mm-hmm. And I think that's a really emerging area for that feedback loop from manufacturing back to design. Right. And that's really powerful.
Right. Wow. So, Jennifer, I mean, Arch has been very successful at really capturing 90% of the Tier 1 market. I mean, it's huge. You literally can control the whole end of the market. How do you get into the Tier 2s?
Yeah, I mean, I think if I think about, there's two things I think that we need to consider here. One is, you think about the level of the technology and where it's able to reach. I think we talked about this previously before. You've got to be able to meet the data where it is with the level the Tier 2 manufacturers, right? And it's now able to do that. It doesn't require the level of complexity, the level of connectivity. It doesn't require that full breadth in order for the Tier 2s to get the value from it that they need. Right? Mm-hmm. So now that we can do that, you meet the data where it is, you meet it at the price where it is, you meet that availability where it is for those Tier 2 manufacturers. It's much more available to them now than it was a few years ago. Some of these tools make that possible. The other thing I want to make sure that, as we talk about the capability, and this is going to be as true for every tier of manufacturing, everyone is struggling with the ability to have seasoned technicians to be able to, there's just a huge talent gap.
Yeah.
And it's growing. It's getting worse. It's not getting better. We're losing the talent faster than we're replenishing it.
Right.
That's where these tools are really, really impactful for the organization. I think when I talked earlier about, why are our customers becoming more comfortable with it? I think they're seeing that it enhances their job rather, especially in manufacturing right now, we're seeing it enhancing their job rather than coming and replacing it. That's because that knowledge, that tacit knowledge that's sitting inside of those very, very, very valuable seasoned experts in the factory needs to have a place where it can then make its way and be transferred and become extrapolated across the organization. And these tools allow that to happen. So it's very, very, it's impactful to the organization's bottom line, to their ROI. The organization's happy because they make money off of it.
Right.
But the users are very happy because it significantly improves their day-to-day job, and that they're not spending all of the time writing SOPs over and over and over and training things that don't have to be trained anymore. The tools can help do that, and then they get to do more enjoyable, higher impact work.
So are you saying that the tools are learning and the software is learning off of the actions that the engineers are taking, basically, and through trend analysis and different things, they're sort of making.
Yeah, you heard Tim mention
decisions.
Yeah, go ahead.
Yeah, no, exactly. So this is something that is a really important point, right? So sometimes people confuse these new AI tools with the older generation of machine learning.
Right.
And machine learning is like, I'm going to train my own model. I got a bunch of examples of data and labels. I'm going to find some way to predict it. And those are like black box, hard to explain, hard to manage, and typically very costly to build. These new AI, they work on the basis of text and reasoning and language. So what that means is if an engineer puts in a comment, hey, this wasn't right, actually, this is what I solved it instead, that exact comment can be fed in to a future run of the model, and now it has, here's my SOP, here's all the data, here's the previous 5 times engineer saw this exact problem, here's what they said, and it reasons based on all that information. So that natural feedback loop and learning of taking what someone understood, taking their written summary, and using that to inform our next decision, it's the same way an expert person would do it. And these models naturally work that way. And it's been a very powerful unlock because, as you say, that's all you need to have, that learning loop. Even if the model is great, you need to be able to get it progressively better over time, do continuous improvement. And having it be able to work directly on the comments, the recommendations, the findings of people in their native language is very important.
But I mean, the data it's taking, is it taking the data from written evidence or is it taking it from verbal evidence?
So it can take from both, actually. That's kind of interesting. So one of the early features we put in on AI was automatic speech recognition. So rather than needing to write down a comment, just speak a comment in whatever language is spoken in the factory. It will transcribe it, it will translate it, and then now it's available then. So at the end of the day, it works on written, but it can automatically create the transcript from spoken word. So we actually have a very nice implementation in a medical manufacturer on injection molding, where one of their challenges is they had a very complex regulated downtime classification scheme. They had to label all the downtimes on their line according to 200 different reason codes, like very specific, tracked because of regulatory compliance, and nobody could remember which one to pick. They had to actually go off the floor to a binder to look up what was the reason that they're supposed to pick. Now they just say what they saw on the machine, AI transcribes it, and then matches it to the reason code based on what they saw. And it's had incredible adoption because it's just so much easier to use and meets the compliance burden, but in a much easier way on a daily basis for the operator and the technician.
Right. Wow, that's incredible. So I want to circle back on the question I asked Jennifer earlier, and that is, of course, how do we get the tier 2s involved? I mean, so what would you do specifically at product level to bring them into the fold?
So when I think about the tier 2s, one of the big challenges historically has been you're not going to be able to get the same level of connectivity and data across a shop floor. They just won't have the same level of equipment. It might be older. It might not have some of the data upgrades that we typically would expect from the tier 1s. So what we do at the product level is we identify what are the ROI generating use cases and what is the minimum data you actually need to drive that use case. So for example, this quality root cause investigation. That's a high data use case. I need an MES. I need strong quality data. I need a lot of machine data. But if I want to increase UPH performance, I may just need one machine in the line that gives me a heartbeat, and I can run a very powerful UPH improvement. If I want to do process optimization, maybe I only need an AOI and an SPI connected. So we start identifying like what are the wins you can get with your equipment as it is, what drives value today, and the tier 2s over time may choose to upgrade, they may choose to buy newer equipment, but we need to meet them where they are and be able to provide value immediately based on data that is available and based on use cases that work with the machines they have, not the machines they maybe wish that they might have in the future.
Right, yeah. And you can pull some of that data off using middleware and stuff like that.
Exactly.
But yeah, I totally get it. You know, that's the way to go. It's fantastic work that you guys are doing. I've got 10 more questions I could ask you, but of course I don't have the time to do that. But I really I'm superbly impressed with Arch and everything you do, and I want to thank you for coming in and talking about it today.
Yeah, thank you for the opportunity.
Yeah, happy to do it. Thanks, Trevor.